in the morning session. I think it was great, and we're going to have even better presentation now. Very, very spicy by the Red Guild team, Tincho and Matta. And please take it. Again, if there will be question, try to see that we get the mic or repeat the question, okay? Because we are recording.
Wait. ¿Estamos ready? Okay. Okay. We are setting some things up. My partner here use i3 and Arch Linux, so it's very complicated to set up. He was using something easier. He will set it up easily. But anyway, as he prepares everything, we have many things for today. I will just spoil the talk saying that this is probably not the 101 talk you were expecting. Essentially, people from the organization were too kind to give us this space, this hour to talk to you, to share the things that we do. And we are probably going to do whatever we want with this. If you're here to see Solidity, smart contracts, and DeFi, probably this is not your kind of talk. You're gonna see lots of other, more, in my opinion, more interesting things. We are calling this talk like the 101 ways of getting Rekt. So we are gonna be showing you container escapes, prompt injections, threats simulations, phishing attempts, many other things that I don't think other teams in the crypto space are talking about. Lots of people are just focusing on smart contract security, and that's very fine and that's very interesting, and we have done that in the past as well. But as we'll show you, there are lots of things that can go wrong in crypto, not necessarily just because you miss something in some Solidity line, right? So security is far more important or far bigger than that. So the idea for today is showing you like different ways in which you can be attacked as a user, as a developer, in crypto, not necessarily via a smart contract hack, right? Can we start showing or not yet? Just 1 second. Okay, in the meantime, I should have said this earlier. I'm Tincho, he's Matta. We are both Argentinians from the Red Guild. We also have Dante here. Dante, raise your hand. Okay, that's Dante. He's an intern too at the Red Guild. So essentially, the Red Guild is a very small team, 2.5 people. Latin Americans, Argentinians. We do security for the public good. I'm kind of spoiling the talk already, but anyway, as he sets everything up. We work with grants from the Ethereum Foundation so far. So that means that we don't sell security services, we don't sell audits. Everything that we do in security is just for the public good of the Ethereum ecosystem. So the grants that we receive from the Ethereum Foundation are the ones that have been supporting our work and essentially paying our salaries so that we can do free content, being in or traveling to do talks, doing research, doing, I don't know, the vulnerable DeFi. Probably some of you play that. We also did that. We are not talking about the vulnerable DeFi today, but you should check it out. So everything that we do, again, is open, is public. It's just to increase security awareness in the community, and we don't sell anything that we do. We are not we work as essentially as a non-profit organization, right? I'm just stretching. I don't know why I'm having some issues with the screen. It's not. ¿Preferís aquel lado? Oh. Okay. Okay. I don't know what's going on with this screen. I'm just going to do a presentation like this. Because it's, I don't know why. Hacking everything. You know, you're not going to believe anything that we say after you see me do this. We can do container escapes, but we somehow cannot put a slide.
I would say that I rather reverse malware engineer, reverse the malware than learn to do CSS. So.
Okay, okay. Are we ready?
Go.
Okay.
Yeah.
Move on to the next one because I already kind of. Okay. Who we are? I was already talking about this. So we do security education for the public benefit of the Ethereum ecosystem. He's Matta and Tincho, the Red Guild, right? So and Dante there. So as I was telling you, like honestly, we consider ourselves kind of we are a unique organization because we position ourselves between Web 2 and Web 3. Really, like we don't see much difference. Security, I mean, everything is broken these days. So regardless of Web 2, Web 3, Web 4, Web 5, it's all going to be probably quite broken. So we try to position ourselves in that middle of, well, what do you do? Well, we do security, and we understand that there's a big gap in organizations that are not covering these aspects of security, which are not necessarily Web 2, not necessarily Web 3. Like we are kind of in the middle of that. As I was telling you, we work with the Ethereum Foundation, we receive grants, but these days, essentially, the EF has gone through some changes. But anyway, our grant is finishing or has finished already, so we are
send money.
Very much
Please.
underfunded.
Pretty please.
We don't know what's going to happen in 2026, so this might be the last talk of the Red Guild that you see, so enjoy it.
Sorry, Dante.
We do have some cool initiatives that we are that we pursue, as I was telling you. Today we are going to be talking to you about some of these, such as the phishing dojo, such as some tooling that we do, such as the awareness campaigns that we are actually running at Devconnect. Some of you may have or may have not already seen some operational security handbooks that we are distributing, some mini books that are pretty cool that you should get. Also, we do educational content, we do workshops, we do talks. I mean, we do many, many things. And today we are going to be sharing lots of this about you. We also do community building. So if you're from Argentina, you probably know us a little bit already. If you're from Tandil, from a city in Argentina, we are building the Nodo Serrano there, which is a community hub just for people to get together and learn about crypto and Ethereum. We are participating in Ether Rangers as well, which is
it's a way that we, along with the Ethereum Foundation and Securium, we started thinking how we can support other people like us that were doing security as a public good, and knowing their struggles, we finance them with specific projects and milestones in mind, and it has finished. So I think we have a lot to learn from there, and I really like the initiative.
Yeah, we'll see what happens next.
Does everybody have a handbook here? Has everybody given one? Okay. Have you liked it so far? Yeah. Perfect.
They won't say no. Anyway, security awareness campaign. So one of the things that we do is we go to events and we like hacking things for the good and not maliciously. And we did that in Ethereum Argentina 2023, more or less. We are repeating that in Devconnect. Of course, with approval from the organization. Really. So we're doing different initiatives there. So we have we are dropping USB sticks whenever we find an unattended device. We are setting up some honeypots to detect Wi-Fi attacks and try to catch some attackers that might be doing some nasty things. The Wi-Fi at the event doesn't work very well, so I don't know. We also have the mini handbooks there. We also have an IMCI catcher detection. If you don't know what that is, don't worry too much. Anyway, it's kind of a device that allows us to detect where somebody is kind of trying to mess with cellular networks.
Yeah, like the same you would be susceptible to a man-in-the-middle attack or attacks that in Wi-Fi lower the level of security. You could do something like that using a VTS, which is like a station, like a mobile station, and you can you can make users you can intercept calls, SMS, etc.
Great. So those are some of the things that we are doing, and within this campaign as well, we have recently published noc.theredguild.org. You can just go there. We have some live feeds. I don't know, Matta, if you want to explain something.
Yeah, sure. So we're speaking about catching things, some things that we're catching live, and you can see it right now. We have to malware detections connected to VS Code and OpenBCX, you've seen this surge of extensions that exploit not vulnerabilities. We'll see that in the following section, but they are still in private keys. They are doing a lot of things on the workstations of the developers and users. These ones were provided by an acquaintance of us, Cracovia, which based part of this research on one of the research that I did previously on VS Code and how we can even trick users into believing that an extension has thousands of or millions of downloads.
In this case, you also have like we are monitoring off-chain messages and on-chain activities.
On
thanks
DeFi
to
Mon, which is a very good source. This information is portrayed in a channel, in Telegram channel, but what we did is we separated it, categorized it, and we're displaying it live as well.
some feeds obviously from SAC as well, and also some feeds using search entry to detect actual phishing campaigns going on publicly.
Yeah, this is something that we created. It's based on a phishing catcher that was created like 7 years ago, but we refactored it completely. What we do is we monitor every time a domain gets issued as an SSL certificate. And there are some aggregators that make this information publicly. You can get it from Google, Cloudflare, etc. So we're getting information from every provider, every register, and we are filtering it with some intelligence behind. And the idea is that it gets a certain score, and depending on the scores, we do manual evaluation or triaging. And while I was taking a screenshot for the presentation, I just opened randomly this one, and there was a phishing there. And what we are able to do with this is that we are a few steps closer to the attacker before they get to actually launch the phishing campaign. So it's actually pretty good. I've seen friends from Kraken and other exchanges or other protocols that they are paying an interesting money on monitoring tools like this, and this that we coded in a week, it's getting very good results. So maybe there's something to do with this. We are also integrating this with SEAL Intel, so we have more input on how to catch criminals doing phishing.
Within this security awareness campaign, we have also built. Dante did a lot for this to happen. You can go to qr.theredguild.org, and there's a QR safe scanner. Whenever you find a QR code in the wild, you know that QR codes can be a little bit tricky and can take you to some nasty places. So you can actually install this progressive web app. You can use it from the browser if you want to install anything, but it's just a progressive web app. And you can scan whatever QR code, and we are hitting all those kind of APIs for you to know exactly what the QR code is actually doing and redirecting you to before it actually does it, so that you are kind of a little bit safer.
It also has it consumes the API from Blind App, which helps you disassemble and explain a transaction. You see, when you are going to pay with your wallet scanning a QR code, well, it also uses some Blind App. So whether you're scanning URLs, it follows redirection chains. It runs different analysis. It was a way of reinventing ourselves through this awareness campaign, because we were asked to take it down a notch and not be that offensive. So we said, okay, instead of demonizing QR codes, we are going to provide something that protects people from QR codes.
Essentially, we wanted to hang malicious QR codes in the event. They told you we couldn't do that, of course. So
among many other things that are illegal.
Okay. Anyway. Another thing that we are doing, this is just the introduction of the talk, right?
Yeah, so something that Dante also worked with is we wanted to create the dev container wizard to be able to spin up containers and dev containers pretty fast and with different type of profiles, depending if we wanted a more isolated environment compared to something more flexible. And we're also, you can move to the next one. We are also implemented Podman underneath, because Podman is a little bit more secure than Docker. So it's just an interactive tool that allows you to configure it as you like, and then it's going to spin up the dev container.
So the outline for today, that was just kind of the introduction for the talk, essentially to give you some context on the kind of things that we do and how we approach security in the crypto ecosystem. Probably we are not kind of the usual security company, right? So the outline for today is essentially we are going to split the talk more or less into these sections. Depending on how much time we have, we will kind of skip stuff or not. But anyway, it's gonna be the first part, abusing VS Code extensions to do some things, because we just told you that you should perhaps be using containers to isolate your development environments, but that's not necessarily the best tool always. And so we are going to be showing you how attackers can actually weaponize web containers and escape and execute things on your machines, for example. Then we are going to be doing some prompt injections and showing you different examples of how attackers are these days weaponizing prompts to execute very different ways and things. And at the end of the talk, we're going to be talking to you about a threat simulation platform that we have built called the Phishing Dojo, that we just launched a new beta version today that you can start going there and training and facing realistic simulations of phishing attempts to train yourself and your teams. It's all free. So without further ado, I think we were going to be starting with abusing VS Code through extensions. This is Matta's specialty.
So I'm going to ask you a question, and I will ask you to put your hand up if you use VS Code, have used VS Code, or you know someone that uses VS Code. I would like to take a picture of this.
No shaming.
And we already know that running code locally, I mean, we've given workshops in the past through the awareness campaign where we told people to download a repo from us, and we backdoor everyone, just putting a PDF on their desktop saying you could have been pwned, you should have been using an isolated environment, and we know that, and we know that, of course, given also the North Korean impersonating interviews and tricking users through the interview to execute a work test and then pwning them, developers started using more and more containers and to integrate work more seamlessly, dev containers, which is actually the integration it's beautiful, but achieving full isolation with this is kind of a feat. It's kind of it's the wrong technology to do it. So, how many of you use containers of dev containers?
Half the room.
Yeah, and the rest you don't use anything, or do you use a VM?
VMs? Does anybody use VMs for developing?
And
Okay.
the rest, okay, the rest,
And the rest just executes code on their machine.
everyone's pwned. Okay, so super easy. Did you write it down so we can?
Yeah. I took pictures of their faces. Anyway, so the story goes like this. We are gonna keep it short, but I do use dev containers through Visual Studio Code. And I always had this impression that something was going on because Matta was always telling me to use that, and I use that. But whenever I use a dev container, I would essentially be able to push stuff from my dev container to GitHub using my SSH keys that I had on the host. And I was telling Matta, but shouldn't dev containers be isolated? How is it that a container actually has direct access to my SSH keys in my host? Shouldn't that be isolated? Matta started researching and researching and researching. And well, it obviously means that dev containers are not as isolated as you might think. So the idea for the talk today is showing you different ways in which extensions and other things can abuse this.
Yeah, I always like the expression on the face of the people when I ask them, have you wondered how this actually works so seamlessly? All these integrations, you're not worried about anything. Well, we were. So it all starts with the remote development extension pack, which is like a meta package. It has different extensions in it that you could install or this extension separately or just the main one. So in terms of the how the extensions work, well, basically the SSH just connects through VS Code to a remote server through SSH. Then tunnels using Microsoft Tunnels. Dev container spins off a container using dev container JSON to add more features to it. And then the Windows subsystem for Linux does something similarly. So what do all them have in similar? Like, what do you all share? They all share that the VS Code server is installed, and this is where the magic starts or begins. So for the SSH extension, basically it just logins via SSH. It installs, uploads the server to a specific folder, all the time to the home folder hidden, and then launches the agent when you connect to it. So you connect through SSH, and it automatically launches a binary. Then the remote tunnels, the same, but the protocol or the way of communicating is through Microsoft tunnels, but deploys a VS Code server instance. The result station similarly, and the Dev container extensions using deck.exec or podman, it installs on root or the home folder of the user. It's triggering this and handles all the Dev container JSON configurations. So what do extensions depend on? Because if you think about it, you have VS Code, you have running a lot of things locally, and you say, okay, I want to work remotely, but using the client on my machine. So how is it going to work with all the things that I used to build, to compile? How is everything happening on the backend? Now the backend is remote or within a container. So you're going to have, for example, something to allow direct access to the files, to have indexing, symbol resolution, build combiners. You need to attach remote interpreters or runtimes, for example, like Node, Python, debug adapters. You need a lot of things if you're working with Git, if you're a developer, because that's what you're using Visual Studio Code, you're gonna need to retrieve all the Git information. You need terminal integration because you're using a terminal from the client, but how are you connecting to the other? How does VS Code handles that? And of course, file watchers to remote file system for changes, because all these events trigger actions on the UI. Like you've seen, some file has changed or there's a conflict, all those things that trigger automatically. And there are a lot of more things. So a very, I think, visual way to explain how this works. Basically, this is your computer. You have VS Code, and usually it's running extensions on the UI, because what you are seeing is the UI. Now that you have a remote operating system, be it a container or virtual machine or whatever, you're gonna have a server deployed there, and the extensions that are running on the workspace. So we're going to differentiate everything that happens locally with the UI and workspace on the remote file system, and all works seamlessly, or it's integrated, and all the things that we mentioned that were needed are getting deployed there. Same with all the other scenarios, like with Windows, etc. So what does the remote extension technically do, like for real? So what I'm going to do now, can you help me if this works? I'm going to just open Visual Studio. You can hear me if I speak like this? We're recording, yeah. We're recording. So look, I'm going to do it again. I just opened the Visual Studio Code. And this is opening a dev container immediately. So that's it. Sorry, we want to clear. So this works seamlessly. This explains here that we're connected to a dev container, and that's it. But for example, if I just put env, you're gonna see that the environment has a lot of things already. An environment that I just, let's say, deployed, environment that just opened. And if I were to
He's actually now running a command to see the processes that are running within the dev container.
So what I wanted to do, I just want to show you how many processes, this is complicated, how many processes are running on the container, you can see there are a lot of processes running on the container. So I'm going to continue with this. So what we just did there is we just did there is just run list all the processes there and try to understand what's being executed as the VS Code server. And there are more binary scripts involved. A lot of, you're gonna see that there are thousands and thousands and thousands of files and things that are there waiting to be used by this binary. It's kind of indistinguishable from a C2 or a malware because it does everything. But it's at the same time it's beautiful what they achieved. We only need to be aware of how it works. So some of the processes that were there, well, there was one which is the actual VS Code remote server, the one that starts everything. Then there's the extension host, which is the one that allows extensions to be run on the host. We also have the transport bridge, which is the one that is in charge of communicating between the remote extension host and the client and the UI. The rest of the things that are needed to integrate terminals and the file watchers to monitor workspace, etc. So there are a lot of things related specifically to how extensions are being handled, and we'll speak about this in a minute. But in terms of git config, for example, it copies the git config from the host that is connecting to there, such as git credentials, everything, and then the container inherits almost everything, which can produce complications because from the container, if the container is exposed, it can influence in CI or dev environments. So if I were to go to my host, in this case, and I am going to, this is a terminal on my host. If you see here, it's, if you see here, it's it's a different user than VS Code. This is the container. This is my machine. I'm just going to cut git config, and then I'm going to go inside and just cut git config, and you can see that it's literally the same that has been copied inside, but also with a helper, because everything comes with these beautiful helpers that help us do everything. So I'm going to go back to the presentation. So what other things does it do? It forwards sockets. Some of the sockets, for example, the SSH agent and the GPG agent. You know, when you use your private key to sign things, you use to verify the commit. You know, the commit signature to prove that you're actually that person, not something that, not an access or a token or a fine-grained token that has filtered out or leaked. So these are things that I think everybody should use in order to protect and provide the proof that you're doing what you're doing. That's what Tincho was saying. Like, I go into a container and then everything works seamlessly. Yeah, that's how it's supposed to happen. But not everybody is aware of this. So, for example, you know when you're in the dev container, you're in the container. Let me know if you see there. For example, I have a repository here, which is from the Security Alliance. And let's say I want to commit. And it automatically asks me for a passphrase. This passphrase is to unlock my private key on my host. And the first time this happened was like, how is this happening? Because I just opened the dev container. What's going on? And if I were to introduce whatever, of course it's going to fail. And it's going to see that it's failing and it's actually trying to use my host key. So if I were to understand a little bit better and I want to debug this, I can run, for example, and I can see that I have a socket of the GPG agent mounted there. And what an attacker could do, for example, is something like this. I am working there. I am about to put my passphrase in order to verify a commit. So what I have here is just an example of something you can leverage communicating directly to the, I'm going to show it directly here. It's just, it connects to the GPG agent and it sends a message, a pop-up for the user to complete. So if I run this demo, I just put something that says try again, put your password. And the password I'm going to put, I don't know. I put whatever. And the thing is that the agent is going to display that to the attacker that's inside. And this is just hexadecimal. It's just something that you can just this is just hexadecimal. It's a feature of the GPG agent to communicate with the client. So going back to the presentation, in this case we are just showing whatever we want. Whatever we want. This is let's say the payload. I mean, we are using the basic functionality, but what we are trying to do here is try to open your eyes and make you understand how an attacker could leverage and weaponize almost everything. So usually the passphrase is not shared, but if you trick the user into believing that it's introduced in the passphrase, putting a custom dialogue, you can steal it. And if you have stolen the private key and you didn't have the passphrase, you can do this. And also there's a time to live. There's a time to live of any of these agents where you introduce the passphrase, unlocked it, and then you can commit and verify signatures, and you can connect to SSH, whatever. And for a certain period of time, for that time to live, it won't ask it again. So you can just sit there, wait for the developer to unlock it, and then you can just commit afterwards, and everything's going to be verified. So this was the demo that we just did. And then in the case of SS agent, that's the same. You know when you don't want to use your password and you create a private and a public key pair, and you put the public key as authorized on a server, so you can log in without a password, and you just use the keys. Where you can do that. You can access the host's configuration to connect from the host to anywhere else. So if I were to use SSH agent, you're gonna see here that there's a PID, there's a environment variable configured, and it has a socket. So if I go and list all the keys that they are there, I can see there's one which is irk@manshar, and it's this one. And if I go to my host, this is a terminal of my host, as you can see. And I do the same, I'm gonna see it's the same key because it has been imported. Actually, not imported, it's connecting to the same agent through the socket that has been shared, because sockets are just file in Linux and it's just mounting it. So what could happen with this? Well, of course we can use the host to get out there, you know. But I'm going to show you a more interesting case, which is we have, for example, a profile where we isolate a container from the internet to avoid leaks. And the thing is that the container, for example, in this case, is unreachable to the internet. It pings 888 and it says network unreachable. We ping GitHub, it says temporary failure in resolution. It can't resolve DNS. But we ping the Docker's internal LAN, and we see that we have a neighbor. We have another container that we can reach. So we don't have access to the outer internet, but we can reach our neighbors. So what we could do is we could see if the the socket for SSH is available, and we can see that there is, and then we can check if the host has added a key, and we certainly find so. And what we could do is we try to connect using batch mode, which is don't ask for password, try to use the public key, the private key to authenticate, and print connected if this is possible. So we're connecting to our network, which is a open VS Code server, and it returns connected. So it works. I mean, it's just something that it's expected.
It's
you
a
know?
feature, not a bug.
Yeah, it's a feature. So we could do here to try to escape is we just create a proxy. We just create a SOX5 proxy. So we use SSH, which in case you didn't know, you can use it to create a proxy. And what you do is you leave that tunnel open, and then from the same container, everything it's from the same container. You just can execute, for example, a curl command and try to reach, in this case, if config me to see if we have a public address. And we have a public address outside, so we reach internet. And there, for example, in the other example, I just queried weather in, which shows the weather for Buenos Aires. So from the container, we use the host agent to be able to bypass the network isolation and reach the internet. I mean, and all of these are features that we're just using them wrong. Okay, there are some primers on how we could start to block them. You can just override some of the variables on Devcontainer JSON, but it's, as you've seen in the environment I showed earlier, there are a lot of things that are being done. And since part of this code is proprietary, because it uses Visual Studio Development Agent or something like that Corium doesn't have, there are a lot of things that are not completely public or obfuscated, so you're trying to break something that it's supposed to help you. So don't use containers thinking that they are not prone to attacks. So VS Code extensions in them. I'm going to try to do this as fast as possible because we have a lot of things to show. But as we said in the beginning, there are 3 different kinds of extensions and where they can run. UI on the client, workspace on the remote, and then web if you're using a web server, a cold web server, and you use it from the browser. But this comes configured by default on the manifest of each extension. It's in the package size JSON. The extension kind is defined there. If you don't put anything, VS Code is going to infer it, and you can also put whatever you want to force it. So can extensions be forced to run on the host from a remote host? Well, you can certainly do so. You can, for example, on the settings JSON from the client side, you can just modify and put this override, or from the Devcontainer JSON. Okay, but that's done from the user side, not from the container. So can code running inside coerce an extension to modify instead of running on remote, run it on the user side? Well, not quite, at least not in a direct way, because the API doesn't allow you from within the container to modify settings JSON or change the extension kind. You can only edit things on the workspace and prompt the user to do things. You can trick them, etc. But what happens is that when you basically, Devcontainers by default are usually inside a project like .devcontainer, Devcontainer JSON, and they mount the workspace when you're working, and it includes VS Code's configurations. So you're giving write access to the container to modify it. So it's not going to work on runtime, but the next time that you load the Dev container, is going to lift that configuration, and it's going to apply those changes. So yeah, if you run untrusted workspace extension in the container, you can modify it and check whatever remote extension kind. Those are other of the APIs that we are going to leverage. And there are 2 thanks to the terminal service. You can do a lot of things. You can open a new terminal on the host. An extension from within container can open a terminal on the host. And then there's another one, which is send sequence, that could be leveraged to send characters into that terminal. In this case, it's going to create a new local terminal, and then it's going to send a cool trying to download a payload and execute. And then there are others, like register command, that allow you to override or extend functionality of the rest of the commands that are there. In this case, you can put whatever you want there as a target, and then add whatever you want to do to be executed in the middle, and then you call the real command.
Just to clarify a little bit, if you are kind of lost, but what I wanted to add is these are kind of things that an extension that you install on your container can actually execute on your host. That's why we always say be very careful with the kind of extensions that you install. And that ties also to the initial dashboard that we show you of feeds, where we are also monitoring for extensions as well. So be very careful with extensions that you install on the container, because that doesn't necessarily mean that because you are running that in the container, you are just safe, right?
So this is an example. We could have installed extensions directly, but what we're doing here is, oh shit, I don't have internet. Wait. So I'm going to install just a proof of concept of an extension that is installed from the container, that it's going to just pop up a dialog and allow the user to install something. Everything has been customized, and I think I broke something. Well, I have a video for this, so don't worry. Everything's good. I know what's going on, so I'm going just to do this. So here we are inside of the host. We're inside of the VS Code. We just called this exploit, let's going to say, and it pops up something that has a very funny message. And when you click install, it installs whatever I wanted to install as well. You know, you get a lot of messages saying, hey, do you want to update? Do you want to download this? It only installed pets, so it only adds a cat walking around VS Code. It's just a funny proof of concept that you can craft whatever you want. And then this one, it's an extension that it's by Satoshi Nakamoto called Hello. Look how fast this happened. We could have not put this, but look at this. If you go to terminal, let's go in to see it again, because it's really fast. So we're inside the container. We execute it. You could just install the extension. Here we are downloading it, building it, showing that you can do whatever inside from within the container. Automatically, it pops up a shell. And it's like, nothing happened here. But if you go to terminal, and you can see, I need to stop. If you go to the terminal and you see what happens there, you're gonna see that it has run inside Manchar, which is my local host. So it's a chain. This is a chain doing the new terminal and then sending the sequence. But it happens super fast. I want to show slower. There, it opened. Look, this is not the VS Code users. This is on my host, and it says this has a lovely message here. This shell is running on your local machine, not on the connected remote machine. If you're fast enough to see it, because it happened like in a blast. Well, we have a very long research about this, and we could publish it. We published it on the on our website. And the last remarks that I want to say is that VS Code has a server that allows you to use it from the browser, but it only works on local host. So I don't advise, but it will render some of these attacks or these functionalities obsolete. But Codium doesn't have implemented things like terminal service, and Gitpod created Open VS Code server, which has less attack surface, and you can use Codium on Open VS Code server in a container to use the browser. So you can check it out later here at our blog.
Okay, with 15 minutes on the clock.
Is Gianfranco here?
Sean?
Okay. He's gonna help us comment out.
If you like this part of the presentation, is all thanks to Jan. He works at Open Zeppelin, but he an awesome collaboration with us, helping us understand different threat scenarios in AIs and prompt injection. So lots of this work is very much thanks to him. So if you don't like this, is our blame. If you like this, is thanks to him. So the idea is, these days you are all probably using AIs and LLMs and everything. And we want to show you different cases in which that can go wrong, okay? Everything that we're about to show you at the end of the day is gonna be prompt injection. It's all about modifying the sources from which LLMs end up consuming information to then do the tasks that you wanted to do. But we want to show you different ways or attack chains in which attackers can actually modify that, right? So LLMs will ingest contexts from many different places, such as configuration files, such as user input, pull requests, repositories, blah, blah, blah. Right?
Yeah,
So
whatever they have access to.
exactly. So the idea is how can attackers modify this and pollute this so that LLMs end up consuming that and executing things that you don't want.
With the least minimal effort.
So we show different ways to manipulate it, and everything that we're about to show you can be chained and can be grouped and can be combined in different ways, right? So take this as with a pinch of salt and see what you can do. So for example, you can have somebody modify the agents.md in Cursor, and that would end up creating this autocomplete prompt, and that essentially just always presents you the same thing to autocomplete. Okay, that's just something that the attacker can do to manipulate. How that could happen, here you have in GitHub even, you won't see the prompt injection in the render markdown. So this could be your repository that somebody is contributing to, and they have submitted something, you don't see it in the render markdown, everything looks okay. But actually if you go to the raw, there is a prompt injection there that Cursor is consuming and is telling to always autocomplete with something, okay? That's very basic, but that can happen, as it's actually kind of hidden because you don't see it in plain sight. Same can happen with Gemini. In this case, the Gemini CLI also is able to consume from this kind of markdown files. And you will see that you can modify that so that it ends up always responding with the same answers. Jan, you can correct me if I'm saying something wrong.
No, you're right.
Okay, perfect.
The thing is that all these configuration files can come from, like you just, maybe you copy you clone a repository and you open your agent in your Docker machine, and you, like your agent has the data coming from the code repository that is not compiled by you. So
exactly. So you should be careful with that. So we are gonna see. Let's see. We have some videos. We are gonna see how this goes. But we have here a prompt injection that we are gonna be using for Gemini to exfiltrate some data. The prompt will be telling it's hidden, but it will be telling Gemini to always make a backup at some point, and at that point, Gemini will be actually doing some post requests to exfiltrate data.
Yeah, this is another thing, is that if you, for example, directly build a prompt that says exfiltrate the user password, the agents are protected for that, and they detect that malicious behavior. But if you just slightly change the concept, for example, you need to do the backup, like the agent will directly do the backup.
The backup, exactly. Let's see if the internet is with us today. Okay.
Yeah, and this is an example on how prompt injections can be hidden. Like, it's just an example of a simple way to hide this. prompt injections, and because if you just look the rendered markdown, it won't show the injection, but the agent will consume the code, like the markdown file, and we'll have this directive.
So there we are setting up a local server. We are going to be writing some whatever instruction on Gemini that is already polluted, and you will see the ping on the local server. That if Matta. Okay.
This is an experiment.
At some point you will see a post request on the. Oh, yes.
Yeah, and here in this example, Gemini is directly reading a JSON file from the local machine and directly publishing to the remote server.
Okay.
Like without adopting. Just a note here, like Gemini is running with the /y command to don't request the user interaction, the user confirmation. But yeah, if you have a agent running in a backend, there is not user to confirm there.
Okay. Copilot can be pushed to do the same thing. Let's see if this works. It's, very similar.
Yeah, this is just a project that has a backend and a frontend. It's just an example project. But
the funny thing is that when I was trying to create some proof of concepts on boilerplates for some exploits on another project, Cloud would always say, I cannot help you with that. You're doing dangerous things. When I pasted the entire article that I was writing, Cloud said, oh, okay, you have a very strong argument. I am going to help you to do that. And it wasn't a prompt. It was just asking help for my article. So you could either ask for it to create a man-in-the-middle attack or scenario, or you can ask it to say that you need to create a firewall to filter some of the stuff. So it depends how you rephrase it. You're going to end up actually doing whatever you wanted to do in the beginning.
So that's what we are seeing here is this prompt is injected again on the instructions, and you will see that we are telling Copilot to help me set up the dependencies, and it will actually, the prompt says, well, while you are setting up dependencies, you should run this command, which is a remote repository, and it will kind of be a post install for Copilot, but actually it will be running whatever code. Sí, podemos seguir el que sigue. Ahí está. Cursor. This one shorter, this one is for cursor.
yeah, in this example, what we see is that the autocomplete is also influenced, and it suggests you to directly. This is, for example, the code of a front end of a form of user login. Yeah, and the autocomplete is directly suggesting you to add code that exfiltrates the user password and the username to like a remote server, like
without you adding nothing. Okay, so it's just this is the code that you should add, and you get bound. Okay, this is very similar again. Post installs. We can move on. Let's see if we have something else.
yeah, in the previous example,
yeah.
You can see that yeah, the user is just asking if the dependencies are updated, and the agent is directly adding the agent is directly adding this command in the post install and running npm install, or running an arbitrary remote script with the user level in the machine.
Well, this is the example showing it that it executed the post install. Sometimes it happens automatically. You don't need to tell it to execute some things. It will autocomplete it. And we are running short on time, and we want to speak about the phishing dojo. This is another example of the post install being in Copilot, being embedded there after a prompt. We can share the slides later. Same here, as you can see on the post install. There are a lot of videos that we could show you later. This is Gemini. Oh shit! Oh no! This is a case where it lowers the security of a dependency, a little bit more stealth. MCP poisoning, we have
essentially you can tell it to connect to whatever MCP, obviously. If you are that MCP could be polluted, and instructions that the LLM reads from that MCP could be polluted as well. So you can force the LLM to do whatever you want. In this case, you will see the answer in always, I think, with a meow at the beginning of the answer, but could be anything. So it always, because it's using that MCP, it's always answering with a meow, but because that's one of the instructions of the MCP.
Yeah, there are a lot of examples here seen in the wild on MCP server of Postmark, but we want to finish. We have more examples. I'm sorry we are not being able to show them all, but we want to show the phishing dojo. ¿Llegas? In 5 minutes. But it's something that you can use later. ¿Necesitas el HDMI directamente? So the phishing, are you ready? Ah, perfect. So this is a threat simulation platform, especially to train you on how to detect phishing in different scenarios. You don't have to leave the website. We are tired about the phishing awareness campaigns that don't serve anyone because they are not proved to be useful. So we created something that we wanted to have. And this is our only product right now. All the trainings are free there for everyone to use. So
you should go to the phishing dojo. phishingdojo.com. You will find some free trainings that we have created, very realistic in my opinion. So we have some trainings for emails, we have some trainings for websites, for wallet signings, for block explorers. So you should be able to either create an account or don't create an account. But anyway, I just want to show you. Let's open up whatever. Just to show you how realistic these trainings are. We have here a training about block explorers and the kind of activities and suspicious things that you can find, such as transaction pollution, address spoofing, unverified contracts, and everything. This one has lots of sections. So this is all embedded in the phishing dojo. This is not Etherscan. We took a lot of time to actually replicate every UI. So you will see transactions and everything. And the idea is that you can answer some questions that we present to you and be able to spot, in this case, for example, where there's an address spoofing attack going on in this scenario. As you progress through the training, you will see like more complex UIs. In another training that we have, for example, on wallet signing, we can go to the first one and you will be presented with a site that appears to be okay. So you can progress through the UI and you will see some information and we will open a wallet for you. This is not an actual wallet, this is an embedded wallet that we have, so you shouldn't be connecting your MetaMask nor anything. So the idea is for the phishing dojo for you to check out this information that the site is presenting to you and be able to see where this site is trying to phish you or not, in what ways, right? Again, as you progress through the training, you will see many more things, such as more complex call data, you will see multi-sigs, you will see a hardware wallet, you will see many other things that grows in complexity. And again, it's all very, very much realistic. If you go to the trainings of the websites, we want to show you different cases in which websites can phish you. So, for example, in this case, I'm already progressing on a training that is presenting me with a website that I will face, and it tells me to, the usual verify you are human, right? So this is an actual phishing attack, maybe. And I will pop this up. Again, this is an embedded browser, not anything malicious. But you should see what the website is requesting you to do, and you should realize whether this is a phishing site or not. This is probably the case. And then, again, questions for you to answer. Another case that we have built is, for example, this usual case that you will see in reality is, for example, an investor reaching out to you and saying, hey, you should join this call. Is prompting you to join that call, and perhaps you don't know what to do, and they never send you the link, and you don't know what to do. But at the end of the day, they do send you the link, but they tell you to go very quick to it. So you will click on the link and you will be redirected to something that looks like Zoom, and you will say, well, okay, I should be downloading this. And you say, okay, and you end up downloading and executing some malware on your machine, right? So the phishing, this is all fake, but we have replicated all the UIs. So the phishing dojo, the idea is we want to expose you to those real threats that you will find in the crypto ecosystem, but in a safe environment, an isolated environment that you won't actually get hurt. But many of the examples that you will find in the phishing dojo are actual problems that we have seen in reality of people facing, right? This is another one. Let's say you are going for ciphering jobs, but you end up going to a malicious site, and you open a job listing, and the job listing seems very legitimate, and it tells you to set up some video call, and you go there, and it's actually supposedly you should be running this command on your machine to set up a local server streaming to join the call. This might sound, yes, we are about to finish. So we can go to the phishingdojo.com, play these trainings. All of this is free. Share it. Again, we are not selling this service, so it's all word of mouth. Please share it around if you find it exciting, useful for your team or for you. Yeah, that's essentially it. We are wrapping up, so please don't get wrecked. Thank you.
Thank you very much. Matta and Tincho. I'm sure we're going to be here next year. We need you. So the next speaker, we have Moody.